Welcome, everyone. I'm pleased to be part of this important summit to discuss the 2026 Mathematics Framework for the National Assessment of Educational Progress, NAEP for short, and also known as the nation's report card. It is the largest nationally representative continuing evaluation of the condition of education in the United States. Since 1969, NAEP has informed the public about what American students know and can do in various subject areas and compares achievement among states, large urban districts, and various student groups. My name is Mark Miller, and I'm an 8th grade math teacher and department chair at Cheyenne Mountain Junior High in Colorado Springs, Colorado, with more than 27 years in the classroom. I was a member of the National Assessment Governing Board, which sets policy for NAEP, and served as the vice chair of its Assessment Development Committee when the 2026 Math Framework was approved by the board. I was part of a big team that updated the framework, including the then committee chair, Dana Boyd, my fellow committee members, staff, and expert panelists and stakeholders who played invaluable roles in producing this blueprint. For those that don't know, frameworks determine the content for NAEP assessments and what students are tested on. This framework offers guidance for how developments in educational research, policy, and practice over the past 2 decades should be reflected in the NAEP mathematics assessment. The framework development process is very comprehensive, and this updated framework engaged mathematics educators, curriculum experts, researchers, assessment experts, teachers, and other leaders. A major goal in the process was to ensure that NAEP is designed and implemented in ways that allow all students to show their best work in terms of what they know and can do mathematically. The updates approved by the board reflect modern expectations for students and address recent standards, curricula, and instruction, research on cognitive development, and the latest perspectives on what students should know and be able to do. The board last updated the framework in 2006 for the 2009 assessment, so we knew it was time to make sure NAEP modernized appropriately to reflect the landscape and maintain NAEP's high quality and rigor. The NAEP mathematics assessment measures what mathematics students know and are able to do, which involves understanding of particular mathematical ideas, what we call the content. The content can be thought of as nouns, numbers, data, variables, functions, graphs, and so forth. There are 5 content areas I want to describe. First, there is number, properties, and operations. It includes computation and understanding of number concepts as a major expectation of the NAEP mathematics assessment. In grade 4, students are expected to have a solid grasp of whole numbers as represented in the base 10 system and to begin understanding fractions. By grade 8, students should be comfortable with rational numbers, represented either as decimal fractions or as common fractions, and should be able to use them to solve problems involving proportionality, percentages, and rates. At this level, number sense should also begin to coalesce with geometry by extending students' understanding of the number line. This concept is connected with approximation and the use of scientific notation. Grade 8 students should also have some acquaintance with naturally occurring irrational numbers, such as square roots and pi. By grade 12, students should be comfortable dealing with all types of real numbers and various representations, for example, like powers. Students in grade 12 should be able to establish the validity of numerical properties and using mathematical arguments. The second is measurement. Measurement in this framework includes use of instruments, application of processes, and attributes such as capacity, weight, mass, time, temperature, and geometric concepts of length, area, and volume. Many of these attributes appear in grade 4, where the emphasis is on length, including perimeter, distance, and height. More emphasis is placed on area and angle measure in grade 8, and by grade 12, the study of volumes and rates constructed from other attributes, such as speed, is emphasized, as well as measurement in everyday life. The third is geometry. geometry in the framework includes spatial reasoning and applying geometric properties, including congruence, similarity, and symmetry. By grade 4, students are expected to be familiar with simple figures and their attributes, both in plane, like lines, circles, triangles, squares, rectangles, and in space, like cubes, spheres, and cylinders. By grade 8, understanding of these shapes deepens with the study of properties of plane and solid figures, including cross-sections of solids, congruent and similar transformations, placing figures on a coordinate plane. Also provides the beginnings of the connections among algebra, geometry, and analytic geometry. In grade 12, the content of plane geometry is logically ordered, and students are expected to make, test, and validate conjectures. The fourth, data analysis, statistics, and probability. This includes graphical displays and refers to the entire process of collecting, organizing, summarizing, and interpreting data. By grade 4, students are expected to apply their understanding of number and quantity to consider questions that can be answered by examining appropriate data. Building on the principles of describing data distributions through minimum, maximum, and clusters of values. By grade 8, students are expected to use a wider variety of organizing and summarizing techniques for center, spread, and shape. Also by grade 8, students are expected to begin to use more formal terminology related to probability and data analysis. They can identify associations between two numerical variables in scatter plots, as well as the relative strength of those associations. By grade 12, students are expected to use a wide variety of statistical techniques for all phases of data analysis, including a more formal understanding of simulation as an inferential analysis tool. The last is algebra, which involves expressions, equations, representations, and relationships. As students progress through grades, they continue to engage in algebraic thinking, and they add more algebraic formalism to their repertoire. By grade 4, students are expected to recognize and extend simple numeric patterns as a foundation for a later understanding of function. They begin to understand the meaning of equality and some of its properties. As students move into grade 8, the ideas of variable, covariation, and function become more important. By using variables to describe patterns and solve simple equations, students become familiar with manipulating them. Representations of covariation in tables, verbal descriptions, symbolic descriptions, and graphs can combine to promote a flexible grasp of the idea of a function. By grade 12, students are expected to be skillful at manipulating and interpreting more complex expressions. Nonlinear functions, especially quadratic, power, and exponential functions, whose graphs are accessible using graphing technology, are used by students to solve real-world problems. The distribution of items among the various mathematics content areas is a critical feature of the assessment design because it reflects the relative importance given to each area in the assessment. This slide describes the percentage distribution of items by grade and content area. As has been the case with past NAEP assessments, the categories have different emphasis at each grade. It also should be noted that at least 1/3 of grade 4 number, properties, and operation items should assess fraction content. The NAEP framework development process actively engages NAEP constituents over a 2 to 3 year period. There are numerous steps, including input from stakeholders through public comment, expert panels and advisors, multiple revisions, before the board finally approves a final framework. Another extensive process is the implementation of the assessment by the National Center for Education Statistics, which administers NAEP. NCES develops assessment items and contextual items, and then completes multiple rounds of testing and reviews before all items are finally approved by the board and finalized for the assessment. You'll be able to get more details on these steps from our one-pagers on the Summit Resources page for the math framework. Math skills are essential for the overall academic achievement of our nation's students, their successful participation in the workforce as adults, and the economic progress of our nation. NAEP, in conjunction with other data, provides critical information that educators, policymakers, and families should use to inform and improve teaching and learning. This slide is a summary of the post-pandemic NAEP mathematics assessments. These have provided an invaluable spotlight on pandemic-era learning in math, and I want to share some highlights from recent reports. First, we will look at the NAEP long-term trend, or LTT, as we sometimes call it. It is a special age-based assessment that has measured foundational skills for 5 decades. The LTT provides national data at the 9-year-old and 13-year-old levels. It is different from main NAEP, which is more rigorous and provides national results at the 4th and 8th grade level, and also by state and 27 urban districts. When the LTT results for 9-year-olds were released in September of 2022, we saw the first ever drop for 9-year-olds, 7 points compared to 2020. We do see the improvement compared to the 1978 test of 15 points. Unfortunately, there was more bad news. As we dug in deeper to the test, there were declines among all percentiles over the same period of time. For example, students in the 90th percentile scored 286 in 2020 and scored 283 in 2023, a 3-point drop. Compared to the students in the 10th percentile that scored 191 points in 2020 and then dropped to 178 in 2023. These were especially significant declines for low performers. When we look at the results for 13-year-olds that were released just this past June, the picture was not any rosier. Scores for that group dropped 9 points to 1990 levels, and just 5 points greater than 1973. And similar to what we saw for 9-year-olds, there were declines seen among all percentiles, and even greater declines for low performers, and greater declines overall for 13-year-olds compared to 9-year-olds at the highest and lowest percentiles. The 4th and 8th grade data from the 2022 main NAEP assessment we released in October featured findings at the national, state, and urban district. Like the LTT assessments, this was the first post-COVID report card. The report showed scores dropped sharply since 2019. These were the largest national declines we've ever seen in math. What's more, we saw declines in all 50 states. This map represents the number of tests out of the 4 that were given: 4th grade reading, 8th grade reading, 4th grade math, and 8th grade math that showed a decline. Some states declined in only 1 of the 4 tests, while other states had declines in all 4 tests. How did your state do? My home state of Colorado declined in 3 out of the 4 tests. Also, grade 4 at the national results had the first ever decline in scores after more than 3 decades, a 5-point decrease compared to 2019. There's still some positive from 1990, but still more declines. And as you see here, the losses were largest for students who were already struggling. The gulf between the 90th percentile and the 10th percentile performers is widening. Now here we have grade 8, a level near and dear to my heart. Unfortunately, we saw the first ever score decline for this grade in well over 2 decades. This was heartbreaking to me, as I have witnessed teachers, schools, families doing everything that they can to ensure students are making progress. This really is an urgent call to action to use the data to help all students succeed. And again, students of all levels experience steep declines in math. Additionally, the declines are across all mathematical content areas. It's not just in one area. It's not just algebra or just geometry, but it is across all percentiles, all skill sets, and all areas of knowledge. These findings represent the challenges all of us faced during the pandemic. Many of my own students faced difficulties in navigating the many interruptions to learning that occurred during the pandemic. And going forward, I continue to see learning gaps among my students because of the ground some of them lost. However, I have also seen a renewed drive to learn, to be creative, and to experience learning in new ways. Personally, I miss the daily interactions with my students and the energy they brought to the classroom. I realized the importance of building relationships with my students, and I needed to increase our focus on creating a positive culture and climate to go along with math discussions, to build a stronger community and increase our mathematical understanding. The data NAEP produces has been and continues to be valuable to policymakers, educators, and other leaders to inform policy and practice to improve achievement for all students. This is why the framework matters, especially amid historic drops in scores at every level and across every knowledge area in math. Providing a guide on what should be assessed to continue to measure progress is imperative. The board saw it was important to update the framework for the 2026 assessments and beyond to make sure NAEP maintains the gold standard of assessment and provides data on performance reflecting changes in education and testing. We developed a video where I take you through what's new and unique for this new framework, especially the practices. Watch this overview, and I'll go into more detail on how we're ensuring NAEP continues to measure math achievement accurately and comprehensively. Our goal today is to make sure that we're working.
I'm Mark Miller, and I teach 8th grade math in Colorado Springs, Colorado.
And I'm also a member of the National Assessment Governing Board. A main responsibility of the Governing Board is determining what should be tested on NAEP assessments. This is reflected in NAEP frameworks, which guide the content and design of the assessments. The Governing Board recently updated the framework for the NAEP Mathematics Assessment. One of the most significant changes to the mathematics framework is the addition of 5 mathematical practices. These practices have been crafted for NAEP assessments. Let's go through them.
Representing, recognizing, using, creating, interpreting, or translating among representations appropriate for the grade level and the mathematics being assessed. Abstracting and generalizing, decontextualizing, identifying commonality across cases, items, problems, or representations, and extending one's reasoning to a broader domain appropriate for the grade level and the mathematics being assessed. Justifying and proving, creating, evaluating, showing, or refuting mathematical claims in developmentally and mathematically appropriate ways. Mathematical modeling, making sense of a scenario, identifying a problem to be solved, mathematizing it, applying the mathematization to reach a solution, and checking the viability of the solution in developmentally and mathematically appropriate ways. Collaborative mathematics, the social enterprise of doing mathematics with others through discussion and collaborative problem solving, whereby ideas are offered, debated, connected, and built upon towards solution and shared understanding. Collaborative mathematics involves joint thinking among individuals toward the construction of a problem solution in developmentally and mathematically appropriate ways.
These mathematical practices will pave the way for NAEP to capture a richer picture of student achievement and engagement with mathematics. Learn more about the updated NAEP Mathematics Framework. Visit www.nagb.gov.
NAEP mathematical practices are the routines, norms, and processes needed to do the work of math. I mentioned before that the NAEP Mathematics Assessment measures what mathematics students know and are able to do in terms of content, which involves understanding of particular mathematical ideas. Practices involve how to use those ideas in mathematical activity. These practices will provide a deep understanding of what it means for students to be able to know and do mathematics, reflecting decades of efforts to specify processes more clearly, like higher order thinking and mathematical reasoning. In this slide, you'll see each of the 5 practices and the estimated percentages of items that will fall under each one on the assessment. The distribution is fairly even and covers a lot of ground. Most NAEP mathematics assessment items will feature one of the 5 NAEP mathematical practices, somewhere between 55 to 85%. The balance of items, 15 to about 45%, those in the other category, will assess knowledge of content without calling on a particular NAEP mathematics practice. So let's make this a little more concrete. Here's an example of a kind of question that could be asked on the 2026 assessment for grade 4 that would fall under the mathematical representation category. I want to emphasize that this exact item will not appear on the new assessment, as this example is pulled from the 2017 administration, but the question represents the type of skills 4th grade students would have to demonstrate to answer this correctly. Can you find the correct answer? If you said C, 3025, you passed with flying colors. High five. Updates reflect the last decade of changes in state standards for mathematics, curriculum, instruction, and assessment. The framework incorporated findings from several reports that compared NAEP and state standards, mathematics content taught in leading countries around the world. We have looked at a couple of the updates already, content and mathematical practices, but it also includes a few other major changes from the previous framework. I want to cover 2 more areas that represent changes to the math framework. The first is a deeper concentration on mathematical literacy. Essentially, it's the ability to apply mathematical concepts to everyday situations. Some objectives at grade 12 are identified with the theme of mathematical literacy. Those items might be given in real-world contexts, such as solving a problem about tax implications of a workplace policy change. It's important for every student graduating high school to be mathematically literate, whether or not they attend college or pursue a field like engineering that heavily involves math. I like to say everyone is a math person. A large body of experiences can be viewed as requiring mathematical literacy, including fluency in the broad range of mathematics of personal finances, understanding statistical information and displays found in print and visual media, and household tasks such as cooking, cleaning, furnishing that require a variety of measurements. The second change is item formats and technology in assessments. The new framework allows for use of interactive, multimedia, scenario-based tasks. By expanding formats, the aim is to provide greater access to all students, as well as to diversify the ways in which student achievement can be recognized and measured. Technology is a part of every student's life and learning, and mathematical thinking should be enhanced by its use. You may be wondering if these changes and innovations will impact trend. I have good news for you. Trend will continue. So we will still be able to measure progress into the future and maintain an important aspect of NAEP that so many people find valuable and useful. Now I'm going to give you a summary overview of what the assessment's new design will look like. First, the assessment will incorporate a mix of traditional and innovative item types that reflect recent research on the science of learning. Second, the design will capitalize on the use of technology to ensure accessibility, promote engagement for all students, and explore new options for task design and scoring, including the use of multimedia. Third, it will keep up with the times by continuing prototyping and research to capitalize on the capacities of current and emerging technology. This will allow us to assess students at deeper levels while still ensuring validity and fairness of scores. Lastly, the assessment design will carefully balance promotion of more valid assessment of mathematics content and practices without compromising fairness or reliability. For example, this would involve fairness in terms of students who have less access to technology. Now, I don't want this presentation to be the last time you engage with us on the NAEP Math Framework or the valuable NAEP math data. You can still stay informed and involved. First, download materials from the Summit's resource page to learn more about the NAEP Math Framework. Second, look at the Nation's Report Card. It's at www.nationsreportcard.gov to explore math data and use tools such as the state and district profiles to see how your state and urban district has performed over time. The value of the NAEP assessment is the results themselves. The findings provide valuable information on a national scale you can't get anywhere else. And we want you and other leaders to use NAEP data, along with other data, to inform policy and practice that will benefit all our nation's students. In addition to the Summit's resource page, you can visit the websites of the National Assessment Governing Board and the Nation's Report Card for more information and resources going to the URLs you see here. Thank you everyone for your attention to this presentation and for being part of this important summit that gives a much needed focus to mathematics learning and instruction. I look forward to answering any questions during the Q&A portion.
Welcome, everybody. I really appreciate you joining me today and taking a look at our NAEP Mathematics Framework. I am here and available to answer some questions. If you want to put your questions in the chat, I will answer them for you. Looks like, James, I appreciate you being here. You are up with the first question. And the question is, what do you and your colleagues at the building level do with the data from NAEP? How do you find it useful? James, that's a great question, a question often get asked. NAEP is the only nationally representative assessment of students that so we know and can do, and math and other subject areas. And it really is at the national, state, and large urban district level. However, that information provides invaluable insight that can inform policy and practice that will hopefully improve and ultimately improve student achievement nationwide. Specifically to my classroom, I know that I have used the NAEP questions tool. It provides sample questions. It provides options for students to take tests. The NAEP assessment is really a gold standard when it comes to the quality of questions. Our teams behind the scene put together great questions. And so there's a few in there that you could pull out to use in your classrooms. And it's a useful tool. Another thing that I've used is the What Works Clearinghouse. And so the What Works Clearinghouse is another place that you can go to pull questions to use in your classroom. But ultimately, we're just trying to make sure that we use the NAEP data, and especially this current data, to increase the urgency with which educators, policymakers are trying to improve academic performance and meet the individual needs of our students across the country. Thanks for the question. All right, got another question. Says, from your perspective, is the most important innovation in the new framework and for students, and what is the most challenging? So great question. Thank you. Appreciate that. So from my perspective, what we've done with the mathematical practices and the emphasis on mathematical literacy is really some innovation that happens, and that has been added to the new framework. We're going to be able to not only look at the content knowledge that students have, but we will be able to look at the practices that students are using to access that content and explain their understanding. When we talk about representing, when we talk about modeling, we look at those mathematical practices, and we can make deeper content understanding about what students are doing now. The mathematical literacy piece is invaluable information that we'll be able to gather that will help us know if our students are prepared for their futures ahead, whether that is college career, whether that is technical work, or whether that is life after high school. We will know what they will be doing, and that we know that they will need their math skills to be successful in whatever they decide to do. And the information that we get about mathematical literacy from the test will help us to know for sure that students are being well prepared for their life post-secondary. Thanks for that. All right, so we got another question. This one comes from Skip. Thanks, Skip. It says, when or what year will the new format be implemented in the next main NAEP? And will this include grades 4, 8, and 12, or just 4 and 8, or their related ages? So this is a main NAEP framework that we implemented, which means it will apply to the grades 4, 8, and 12. The new framework goes through an extensive process where I talked about a little bit before about the process that NCS uses. It's gone through the board approval. The main NAEP Mathematics Framework will come out in 2026. And so in that 2026, we will see the new implementations of this framework. And so that once the board finalized it, then it goes through that process that we talked about. And there's also a page that you can look up to get more details. But ultimately, it goes through a piloting process, and then the results come back, and through that process, they look at questions, items, contextual questions, extensive testing done before it goes out to the 2026 test. So that's a good question. Thanks, Skip. Appreciate that. The ones that you were talking about, related ages, so the 9 and 13-year-olds are for our long-term trend test, which is a different test, not the main NAEP, which is updated with this 2026 mathematics framework. All right. So got another question here, and that is something that I get asked frequently. Will the new framework make the test harder? It's a good question. NAEP has always been a rigorous assessment. Framework updates aren't meant to make NAEP tougher or easier, but rather maintain the incredible accuracy and precision of what NAEP can reveal about student achievement. And so this new framework has an especially deep concentration on mathematical literacy. It's a demonstration of knowledge and skills to solve real-life problems. Measuring this will provide incredibly helpful data for us. And so when the question comes up about it being harder, no. NAEP is the gold standard. It is a rigorous test, but it provides valid and reliable data about our students across the country, both at the state level, the national level, and we have some urban districts as well, 26 trial urban districts that are able to compare results from one place in the country to another. All right, James, got another question here. How prominent is collaborative problem solving in a high school student's mathematical experience? What would have to change? Will there need to be large changes to make it more prominent? James, I am an 8th grade math teacher. My expertise is definitely at the junior high level. I will say that when I look at our framework and what we put in place, I do have some information related to the collaborative problem solving. And so just to give you some expectations, if you will. So students can analyze other students' work. They can justify, agree, disagree with claims made in geometric problem-solving situations, collaboratively generating geometric proofs, generalizing geometric ideas, contributing to problem-solving areas. When it comes to data, statistic, and analysis, they analyze models constructed, revoicing and restating what others are claiming to be true. And so verifying the conclusions of others. I think part of it is just getting at the idea that for post-secondary use, the collaborative nature of careers is going to be improved with more emphasis placed at the high school level. So appreciate that question, James. Thanks. All right, we are coming down to just a couple minutes left. If anybody else has another question you'd like to throw into the chat there, I'm happy to answer another question. If not, I don't see one jumping out there, but if not, I do have another one just thinking about the declines that we've seen and potentially things that I've seen in my classroom. So I know that from my perspective at the junior high level, teaching 8th grade, we have had to encourage students to get back in the game a little bit, per se, to jump back in and dive in. We want to hold our students to a high standard, like NAEP does, provide rigorous instruction. But when we're talking about mathematics education, we want to talk about students kind of on the journey. And so the journey can sometimes be a struggle. And we want to teach students how to handle that struggle and handle that difficulty. And think that delivering strong instruction, providing teachers with high quality, professional development so that we can improve mathematics education across K-12. And we can empower students to be strong mathematical thinkers and be able to help them along their journey so that they can have success after they leave us. I only get them for a short time. I know teachers in classrooms, they only get them for a short time. So we need to do what we can to make sure that we do our best to help them reach their goals and reach the success that they need to move forward. So I do appreciate everybody and all of the questions that you've had. I appreciate you, and hopefully you've gained some information from some of the other breakout sessions and the keynote speakers. I want to thank NCES and IES for putting this on. This has been amazing. So thank you to all of you for joining, and appreciate it. We're going to go to break here, so you can transition to your next session if you would like. So take care, and thank you for joining.